in Indian industry. The deliberations today will follow a set of structures, starting with the setting up of the context by the line ministry, keynote address, and then the discussions and deliberations by the panelists. This will be followed by few questions from the audience. I would request speakers to please switch on their video while they speak, and all the participants to keep their mics and cameras off to avoid any sort of disruptions. Participants can post their questions in the chat window, which will be taken up by the moderator later during the Q&A session. Electric vehicle industry in India is a growing industry. Schemes and incentives have launched by the central and state governments to promote electric mobility in the country. And some regulations and standards are also in place. Due to that, EV component industry is also growing at a rapid pace. Today, we are very grateful to have with us Shri Prashant Kumar Ji, Additional Director, Ministry of Electronics and Information Technology, Government of India, to set the context for the webinar. We welcome you, sir. In his current role at the MITI, Shri Prashant Kumar is responsible for venture funding for technology startups, policy framework for semiconductor FAB related activities. He also has an overarching responsibility in other areas related to promotion of hardware manufacturing in the ESDM sector in India. His previous experiences include working in the field of signal processing at Electronics Corporation of India Limited. Over to you, sir.
Yeah, thanks, Shruti, for Shruti and the organizers of this webinar for providing me this opportunity to speak about electric vehicles segment and electronics sector as a whole. I mean, we are at a position where at an interesting time where we are seeing transition in from traditional mobility to electric mobility, and as far as electronic sector goes, here also we are seeing considerable improvements in the electronics production, electronics manufacturing in the country. Government of India has been bringing many schemes, many initiatives to promote various sectors. Electric vehicle segment is one of them, and electronics also. We are seeing multiple schemes which are being launched to enhance the production and the manufacturing in the country. So I'll just cover up some part of the schemes which have been the initiatives which of the Government of India brought in specifically for electronic sector as well as for which are relevant for electric vehicle segment. And I'm sure because there are industry members available in the forum, we would probably be getting recommendations from the industry as to what additional efforts government needs to put to further further promote this segment of the electronics. So Indian automobile industry is a dynamic industry and has grown to contribute in a big way to the Indian economy through manufacturing, through exports, employment, and investment. Be it be it two-wheeler manufacturing, be it four-wheeler manufacturing, be it the tractor manufacturing. It is India stands in top 4 positions in any of the segment. India is the 4th largest market for vehicles, and it is expected to be 3rd largest in terms of volume by 2026. Domestic automobile production increased from at around 2.36 CAGR in last 4 or 5 years, and automobile sector has been generating a lot of employment in the country. The electronic and this automobile sector, the share in global R&D, India also holds around 40% share in the global R&D, and it is also, having consistent FDI inflows. This particular sector, it is around 5.1% of the total FDI inflows during last 20 years. Speaking about auto components sector, the growing presence of global automobile OEMs in the Indian manufacturing landscape has significantly increased the localization of their components in the country. India has become the preferred designing and manufacturing base for most global auto OEMs for local sourcing and exports. The auto components industry also expanded with a CAGR of around 6% during last 4-5 years. And this subsector, the auto components itself, contributes around 2.3% to the national GDP, and is also contributes to the huge employment around 5 million people in this by this sector. India auto component industry is expected to become around third largest in the world by 2025. Coming to the electronics sector, we have been living in exciting times as far as electronics sector goes. The domestic production in electronics items has increased substantially from around 1.9 lakh crore in 14-15 to around 5.3 lakh crore in 1920, with a CAGR of around 23%. India's share in global electronics manufacturing has also grown from 1.3% in 2012 to 3.6% in 2019. India has also, of late, started exporting significantly, and the exports are also, shown 34% growth in year-on-year, in 2019-20 as compared to 18-19. We are actually, these manufacturing is this particular segment, electronic segment, is led by mobile phones, network equipments, chargers, PCBAs are the major items, which are being manufactured. And electronics industry also, is a major provider of the employment, and the mobile manufacturing, electronics manufacturing itself is around, provides around 7 lakh employments as per industry estimates. Ministry of Electronics and IT came out with a national policy on electronics to position India as a global hub for electronic system design and manufacturing by encouraging and driving capabilities in the country for developing core components, including chipsets, and creating an enabling environment for the industry to compete globally. Under the umbrella of National Policy on Electronics, MIT had launched various schemes during last year, during the lockdown. It was basically 23rd of March, the lockdown was announced, and MIT launched around 3 schemes on 1st of April. The first one was Production Linked Incentive Scheme for large-scale electronics manufacturing, which, in addition to mobile phone manufacturing, included specified electronic components, including ATMP, which is a critical part, which is an important part of manufacturing the ICs. Another scheme was scheme for promotion of manufacturing of electronic components and semiconductors, in which MIT had offered, the government of India has offered around 25% incentive on capital expenditure for the identified list of electronic goods, which included electronic components, semiconductor display fabrication units, ADMP units, and specialized sub-assemblies and capital goods for manufacturing of aforesaid items. Another scheme which was launched on 1st of April 2020 was Electronics Manufacturing Cluster (EMC 2.0) scheme, which was providing support for creation of world-class infrastructure along with common facilities and amenities, including ready-built factory sheds, plug-and-play facilities for attracting major global electronics manufacturers and their supply chain to set up units in the country. The electronic sector is particularly, 100% FDIs is allowed, and we are seeing consistent FDI inflows in this sector also. Other than these schemes, which were launched during COVID lockdown, we have been working closely with the academia as well as industry to not only these are the short-term reliefs for the industry to attract the global investments in the country. MITI has been working closely with academia to make it sustainable in the long term, and has been working with academia and industry partners to set up various center of excellences for this sector. Few such center of excellences are Large Area Flexible Electronics, National Center of Excellence for Large Area Flexible Electronics at IIT Kanpur. National Center of Excellence for Next Generation AMOLED displays, which are also quite relevant for automotive segment and EVs. This has been set up at IIT Madras, and also establishment of gallium nitride ecosystem enabling center and incubator at Indian Institute of Science, Bangalore. So coming to basically when we talk about electric vehicles, government has been taking various initiatives to promote electric vehicles, be it promotion, attracting the investments for manufacturing, or be it the driving the demand in the country. Few such examples like a production-linked incentive scheme, which has been allotted around 18,000 crore rupees has been allotted by cabinet for advanced chemistry cell batteries and automotive components, and national mobility of electric mobility mission, and FAME 2 scheme all of us are aware of from Department of Heavy Industries, and national mission on transformative mobility and battery storage. As in any other electronic product, ICs would play a major role in developing the EV markets in India, and ICs is seen as a product which would have a tremendous growth in the tremendous demand in the Indian EV sector. Government is government is aware of the importance of semiconductor fabs and the IC manufacturing ecosystem required for the development of the sustainable electronics manufacturing in the country. Ministry of Electronics and IT, under the guidance of Empowered Committee, had come up with expression of interest, request for expression of interest, inviting interest from the global fab companies, global IDMs, as to understand what are their what would it take for them to come to India and set up their manufacturing units in India. What are their expectations from the government? So we had launched expression of interest around 15th of December last year, and for last 2.5 months we have been interacting with around 25 to 30 companies of this domain to generate their interest, and to understand their interest for Indian ecosystem. And we are quite hopeful that we are going to receive a handsome number of expression of interest in case of we have basically defined 3 categories. One was for traditional silicon chip manufacturing, and another one was for compound semiconductors, which is especially important for electric vehicles. When we talk about compound semiconductors, GaN-based, silicon carbide-based, semiconductors, which are especially being used in high power applications and RF applications. So we have seen good number of companies showing interest in case of compound semiconductors, and a couple of interests which are shown in case of traditional silicon as well. So we are hopeful that from 2 years down the line, we'll be having a good ecosystem where sufficient number of semiconductor fab companies will be present in India, be it traditional silicon or be it compound semiconductors. So since from EV components perspective, I look these two, the battery, which is around half of the cost of electric vehicles as on date, and the importance of availability of integrated circuits. So since NITI Aayog has been spearheading the efforts in case of advanced chemistry cell batteries in consultation with DHI and Ministry of New and Renewable Resources, MITI is spearheading for semiconductor ICs, and we are hopeful that this ecosystem will evolve from 2 years down the line. I would like to stop at this point and would love to listen the perspective of the industry regarding this. Thank you.
Thank you, sir. Thank you for your opening remarks and valuable insight. I would now like to introduce our keynote speaker for the day, Dr. K. Balasubramanian, Director, Non-Ferrous Materials Technology Development Center. Dr. Balasubramanian, Financing and Multidisciplinary EDC at Hyderabad, India, serving as its director over 2 decades. He created centers of excellence, namely CIE for Advanced Materials and Processes, technology. Welcome you, sir.
We can't hear you.
Over to you.
Okay. Thank you.
Yeah, sir. I think I got it.
Correct. Fine. So I won't take much time, except to say where we are and where we should go.
Yeah.
And good afternoon to all of you, and thanks for the invite. And we are at the threshold or at the the springboard of takeoff in electronics and power electronics in a big way. Compared to all other missions like space or atomic energy or defense or even agriculture, we did not create an electronics mission in 1970s, and we are paying the price for it in terms of I would say, call it as backwardness in terms of component systems and whatnot, and solutions. We could have been an equivalent of pharma in this sector, but in electronics things change fast, and therefore we can even catch up on some of them if we get our act together right. Coming to today's theme of quality and standards and other related matters, what we find is that the concept of quality, which is for reliability and reliability, systems level reliability, is kind of very well understood in many sectors, particularly space or defense or any of those big system players. But when it comes to a consumer product or something that is used every day, the numbers are bigger, and so we have to handle large number of components as well as large number of systems. So I would say that, look, we can break this up into 4 levels, and it finally boils down to testing. Test. And can we test more? Can we test fast? And can we get a go, no-go on many of the things? So if I just forget about the standards for a minute and say that the tests eventually give you the standards, we find that the tests fall in 4 levels. The first level is the developmental phase, where we are developing systems or components or whatever. So what we are asking for is a very fast feedback, so that the developer, whosoever is on a breadboard or whatever it is, gets a feedback faster to tune. It could be an embedded algorithm, or it could be there is software in loop, or it's actually choosing the rating of the components. And people who have developed controllers or BMS or any of these EV components would know that they would have fried a lot of breadboards and things, and the faster you burn and fry and come to the solution quickly, the better you are. So a set of testing equipments and testing procedures are around that developmental phase. The next place where they become important and slightly more critical is what we call as in-process QC. Like when you have a number of process steps, we need a go, no-go between the process steps, so that we don't get more rejects in the end, and where a lot of value has already been added. So if I may give an example, I was talking to one of the German manufacturers of power electronic equipments, and what they said was the IGBTs that they were procuring as their inputs, components, they were taking the rating that was given in the data sheet, and they were using it as it is in the design, and they found out that the final product reliability was going down. And they finally traced it to 10% tolerance that was there in the rating, and therefore it's like you buy 1,000 of them, you find that there is a Gaussian curve, and so they started testing each one of them and started putting it in a very, very close band. I give you another example in EV. If you're taking cells in a battery for a battery pack manufacture, the cells have to be within plus minus 0.1 volt. Otherwise, the cells will start discharging amongst themselves, and you get a totally different situation. Anybody who has developed a bearing would know that the ball bearing diameters have to be so close, or they have to be matched opposite to each other, so that you get the final runout tolerance. So in other words, the in-process QC from raw material to the product, it's another set of QC parameters that we do, and you just cannot simply take the ratings that is sitting on the data sheet and then not know the tolerances are being wide and then start working on it. I mean, these are all our lived experience, so it's not just a theory that I'm talking about. The third level of QC comes in what we call as the product performance, which you're going to certify. You're certifying your product. Therefore, you have to have either a statistical or this testing. And here we find that the cost is quite high, and it all depends on, in EV sector, it all depends on how much you want to test. You want to test both software in loop and hardware in loop. Testing becomes important. For example, if you're doing a controller motor battery, these three major components. If battery includes a BMS, then what we find basically is that, how do you test 100% of the motors before it goes to the vehicle on a motor test bed? Your controller, particularly the algorithm, the fine-tuning of the algorithm that was done in the first phase, developmental phase, and when it is integrated to the product between the motor and the battery, it has to pass. And therefore, what you are going to eventually develop is a lot of simulators. You have to have a lot of simulators that into which the critical components are put in, and it becomes a loop. Hardware in loop and software in loop testing comes in a big way. And that's where we find that a lot of apparatus and test bed developments are necessary, and we have to do that as well as a co-product development. And last but not the least, which I think Dr. Deshpande might talk more and better, is a regulatory testing, which is different from development and in-product QC. There are standard cycles and standard parameters that they would test, which might be even different from a duty cycle or a load cycle that we would have taken in the developmental phase. But there is a guarantee that you have to give for the customer, which comes on the regulatory testing level. So you have these 4 levels: developmental phase, the in-process, that is production, manufacturing, process, product phase, and the third is the product performance phase, where hardware in loop and software in loop for performance becomes critical, and finally the regulatory testing. Now let me conclude this short presentation with just a couple of points. When I started these electric vehicle things way back, nearly a decade ago, when we were alone and nobody was around to talk about these things, I used to introduce the system level thinking to people in EV in a very simple way. They said that, look, if you have done 12th standard math, physics, chemistry, you should be able to do that. So motor is all physics, a lot of electromagnetics. If you can rotate a vector in your head and understand the electromagnetic flux, you'll design a motor very well. And the controller is all math. It's fully algorithm. The components are there, yes. The rating, the hardware components are there, starting from your MOSFET, IGBTs to wide band gap semiconductors like silicon carbide. But finally, it is the software that is 60% of the cost. In fact, the software won't be given to you. It is burnt in, it's flashed in, and therefore, we have to have our own developmental software, our own software in India. Otherwise, every controller is tuned to the motor for the highest efficiency in terms of parameters. And battery is chemistry. It's all chemistry. Finally, it's all chemistry. So it's math, physics, chemistry is the play here, and the appreciation of at a system level thinking is required both from development to finally to production. And here I would tell you, like, what we assume as simple is not so simple. I give you a very small example: stator winding. Everybody goes and winds the copper wire, in the stator, which is the flux creating part. The point is that we had the biggest QC problems only in that, because it is still manual. We can't. It creates a lot of employment. In fact, one of the biggest employment generation point is the stator winding. So if you look at that, and okay, if it is 10,000 numbers or more, you can try to develop a machine which is nothing but a hydraulic machine pushing wires inside. But what we have learned is that what is done manually comes out right, unless otherwise the person makes a very serious mistake. But the automated machines have nearly 40% rejections because something rubs against other, insulation goes off. You don't find it, you find it very, very late. So now this is where the difference between Germany and India comes. The Germans go in for a machines. We can create a huge employment, in just this one process step. Not to mention the PCB board manufacturer, where pick and place machines, etc., are all very good, where the QC is done online as it is manufactured. So the mistakes don't happen there. So that's the biggest advancement that has come, which I would call it as in-process QC. So these are all in-process QC examples. And finally, I'll close my address with a very, very small this thing that today artificial intelligence, or I would say machine learning more, specifically machine learning, allows you, as you're doing a development, you're also collecting a lot of data. and therefore you don't want to lose the data at any point. As be it in process, manufacture to product, so you have 100% traceability to the component. Now, because you have 100% traceability to the component, particularly the critical components, when the failure occurs, where it can be traced back. And then the AI, even machine learning, goes even to the level of behavioral identification, how a person drives, and what is a kind of driving behavior, and we can even map the duty cycle of that person versus vehicle very, very easily and start predicting. So to that level, yes, the data acquisition and the learning methodologies, which can easily be tracked to dumped to a cloud and tracked and done, happens. So this is the overall systems level thinking that I would like to present to people, that QC and testing is all over the place, from start of development till the final user behavior, and even when it comes to service or breakdown after it comes. So it's a continuous process, and this is where we have to play a bigger role in giving the reliability and not get into the jugaad solutions. Thank you.
Thank you, sir. Thank you for your valuable insights. I would now like to introduce our moderator for today's session, Mr. S.A. Sundaresan, President, EV and E-Mobility Solutions, Ashok Leyland Limited. Mr. Sundaresan has been an entrepreneur and a technology innovator, designing products and processes. A mechanical engineer by education, past experiences range from developing and business digitalizations, system engineering controls, and digital twins. Currently, as a Vice President Electric Vehicles and E-Mobility Solutions at Ashok Leyland, is responsible for developing new energy vehicles, their aggregates and related solutions. So, over from here. Thank you.
Thank you, Shruti. Good evening, everyone. It's a privilege and an honor for me to moderate this session. We have 5 very eminent panelists covering the entire spectrum. So we have representatives from electric vehicle OEMs, then Tier 1. We have people from standards and testing agencies. And finally, we have a technocrat and an entrepreneur. So we are sure to listen to all shades of opinion and from different perspectives. And we already heard 2 excellent talks from Prashant Kumar and Dr. Balasubramanian. So I'm not going to spend too much time talking about whatever points I have. I will include them and finally when we come to the summary session. Let me first then start with the OEM's perspective. I would like to welcome Mr. Nishant Arya, Chairman EV and Future Mobility, ACMA, and Executive Director JBM Group. To introduce Mr. Arya, he has led JBM to expand its key businesses as well as to transform it from an auto ancillary to various diverse domains and a name to reckon with in each of these industries. He has been actively leading R&D, engineering, diversification, international business, and new projects. His visionary leadership has been instrumental in planning various technical collaborations and joint ventures with renowned foreign companies, including buyouts. These include some key domains such as electric bus, EV charging infra, EV aggregates, engineering and design centers, renewable energy, artificial intelligence, etc. With this background, I would request Mr. Arya to address the following questions. So what exactly are the customers looking for when we go for electrification? And how can industry meet these requirements? So what do we need in terms of ecosystem, partnerships across industries, domains, and even geographies? And what role is the government playing? How does the recent budget fare in pushing electrification? And what more does the industry want from the government? Over to you, Mr. Arya.
Thanks for this iteration. I'll definitely try and address all the points which you have mentioned here. So I have a short presentation. I'll just share that one second. Yeah, is my presentation visible?
Yes, sir.
Yeah, okay, perfect. So very good afternoon to all. I think we have a great panel here, and Mr. Kumar and Dr. Bala have set the stage very well to clearly see that how EV will be playing a key role as we move on with the EV transition in the country, and what we really need to see and how things can transition from where we are today. So just to see that a global e-mobility outlook from my perspective, that how if we are having almost 30% EV transition from up to 2030.
We are not able to hear. Can you adjust your mic?
Hello, am I audible? Hello.
Yes, I am able to hear him.
Yes, sir. Yes, you're fine. You can go ahead.
Okay. So 2 million barrels of oil we'll be saving on a per day basis with EV transition, and only 3 to 4% increase would be there in additional power. So I think that clearly demonstrates that how we as a country have this kind of an opportunity when we are moving into electric vehicles with zero emission. And the kind of number of EV models are getting launched, so the opportunity which any customer has to buy such products, and the charging time at the same time is reducing significantly here from 6 to 9 hours to as low as half an hour. We see as the technology is progressing in next 3 years, and definitely whether we look at any kind of electric vehicles, how they would break even for different customers. But why actually we are talking about EV, I think that is very important for us to understand. So as a country, we are highly dependent. About 85% of our requirements we are importing, and that's a huge burden for us. And at the same time, India as a country where pollution is a huge challenge, transportation is the second largest contributor to the pollution issues which we have. So what do we need to do, and how can we really address this? And because of this, of the top 20 cities, 14 most polluted cities in the country are in India, where we have multiple challenges. There are closures. We have issues in the city, even the capital city of Delhi, with the Parali burning and many other such challenges which are there. So what can we really do and really see that how health and environment is really a focus? So for that, I have tried to capture that actually what are the different modes of sustainability we need to look at, and how can we take a complete perspective from generation to consumption, and at the same time what is the level of disruption it causes to our existing ways of transportation and the modus operandi which people are used to. So here we have given a clear perspective of CNG, biofuels, hybrids, fuel cells, and electric. So going from solar farms to energy generation to distribution and charging infrastructure, I think that is very important. And definitely we'll see that low emission and zero emission technologies, all of them will coexist. And EVs will be playing a very important role, but definitely there'll be a lot of hybridization and other things which will happen in the future as fuel cells come in and as other biofuels also start kicking in. So I think there'll be a space for all, and eventually all of them will be eating out into the diesel and the petrol market, which is there today. But why we are looking at electric today is clearly because the customers, they have certain set of expectations. I am taking an example of electric buses and public transportation here primarily, that how they are looking at the 3C1S as we call it. So clean, connected, and comfortable and safe environment, which is even affordable for them. How the noise levels are going down, the pollution levels are going down. Our import bills is reducing, and quality of life is really changing. And today, what we look at as a need, that is converted into a choice which these people make when they're using these systems. Because even if we've seen FAME, the highest allocation has been given to public transportation, because that is where we are talking about the highest level of